It's on page 214. All right, so we're going to start with number 2. It says the Centers for Disease Control and Prevention tracked cigarette smoking in the United States. How has the percentage of people who smoke changed since the danger became clear during the last half of the 20th century? The scatter plot shows percentages of smokers among men 18 to 24 years of age as estimated by the surveys from 1965 to 2004. Oh. So first, is there a clear pattern, and describe the trend? So what do we see about, or is there a pattern?
Yes.
What's happening?
It's curving up.
Are you looking at number 2?
Curving down. Sorry.
Okay, I was like,
Oh my, yes, it's definitely curving down.
So the percentage of smokers was at a steady decline until around 1990, and then that's where we see a slight increase again.
You forgot your D.
Thanks. I often wonder how in the world I do that, because I do that a lot. Like, I will forget, like, whatever, like, the last letter is of the word. I'm always like, how did I manage to do that? Okay, B says, is the association strong? And just to be clear, it does not have to be linear to be strong.
It's like it's weak and it gets stronger. So I'm gonna play it same.
Okay, what kind of association do you see? Obviously, it's not linear.
Curve.
Yeah. So, yes, it is a strong parabolic association.
Parabolic.
Because it's just like curved. It's just like the one curve. It's just a fancy name for curved.
Oh, that because like when you go in a parabola, it's like a curve.
Yeah.
Oh my gosh. Oh wow.
That's just crazy.
It's okay. I was slightly
It's like,
slightly mind blown earlier when Peyton said that the reason her number is 10 is because her name is Peyton.
We said what?
A10. Haha, that's fun.
Peyton's number is 10.
Oh.
And she was like, yeah, she's like, nobody ever thought of that. And I was like,
Oh, that makes sense.
I never would have put that piece together.
I like don't even like call her Peyton. I call her like Peyton. I don't know.
Yeah. I was like,
I
what?
never would have thought of that. That's funny.
I know. As many times I've written her name, I've never thought about it. All right, part C. Is a linear model appropriate? Explain.
Yes, because technically it is linear to an extent, but then it stops becoming linear.
So, it's not linear, so
Oh,
no. No, because the shape of the scatter plot shows a parabolic model.
I just cannot spell.
It's okay, I can't either.
I spelled scatter with a K and then added an E after the W shows. Well, Taylor gets to play tomorrow. I'm so excited.
I heard she actually ate at lunch.
She did. She ate fries and mac and cheese. She was like, hot food. It was funny.
Taylor?
Who's Taylor?
One of the twins.
She's one of the twins. She has curly hair.
Really
It's
curly
like
hair.
Yellow, red, curly hair. Oh, it's not really red. So.
she doesn't really have red highlights in it right now. But.
She's in our leadership class. She sits all the way. She sits right next to me on the right. He's never paying attention in leadership ever.
I don't.
Well, if you never learn anything, you don't have to.
No, I really think I've only ever heard him say like 4 words in leadership before.
That's only when people ask me.
Yeah,
questions.
it's only when people ask him a question. That's the only time he ever.
I know. All the teachers are like, he's so quiet. And I'm like, not in my room.
I'm like, oh my gosh.
All right. Number 4. The United Nations Development Program, that's a weird way to spell program, uses the Human Development Index in an attempt to summarize in one number the progress in health, education, and economics of a country. The number of cell phone subscribers per 1,000 people is positively associated with the ergonomic process in a country. Yes. Can the number of cell phone subscribers be used to predict the HDI, which was that Human Development Index? Here is a scatter plot of the HDI against cell phone subscribers. So, explain why fitting a linear model to these data might be misleading.
Because it technically does. It's like the problem that we did earlier, where like in certain places there might not be, like in the United Nations, there might not be. Not every other.
Yeah. So, the data doesn't follow a linear pattern. It kind of levels off because it kind of just gets flat at the top and just goes across. If we were going to model it somehow, the best thing to do would be to model it by a natural log, okay, which I'll show you what that looks like in a second. Better modeled by a natural log. Because a natural log would look something like this when it's graphed, or if it's, in this case, would be up the other way. But that would be like a natural log, would be what the graph would look like. And that would be kind of what we would see in Chapter 10 if we were going to cover a lot of it, would be talking about like re-expressing how to rewrite something in terms of what would be the best way to model it. So we don't do a ton with that because there's like maybe 2 problems on the whole AP exam that are going to have that. So it's like, meh. Let's see. B. If you fit a linear model to the data, what do you think a scatter plot of residuals versus predicted HDI will look like? So like if you drew like your best fitting line, okay, what do you think would what would your residuals look like? So your residuals would be the distance between the point and your best fit line.
Kind of far away. Wow.
I think it would be less outliers.
What? I just did not register what you said at all.
Like a few less outliers.
Less outliers? So the residuals would be a mix of positive and negative, but probably mostly negative. Or eventually most will be negative. Because if you take your data and you draw your line through it, your line is supposed to be fitting to, I cut this off. Your line is supposed to be fitting like the middle of your data. So to start out with, it's pretty even, positive and negative, but the farther it goes up, you're going to end up with a lot more down in here, probably. Basically is what that's trying to say. All right, let's see. Number 8. Movie ratings. Does the cost of making a movie depend on its audience? Here is a scatter plot of the same data we examined in Exercise 7, so the problem before it. Movies with an R rating are colored purple. Those with PG-13 ratings are red. PG are green. Regression lines have been found for each group. The black points are G-rated, but there were too few to fit a line reliably. So, anyways. It's kind of hard to tell which ones are purple and which ones are black, but at least in my book, they're very interesting. In what ways is the relationship between runtimes and budget similar for the 3 rating groups? So budget is the Y and the runtime is the X. So basically, what do you see happening as it goes farther?
Like the longer it is, the more it costs.
Yeah. So the budget increases. I cannot spell. Okay. Budget increases as runtime increases. And then, how do the costs for R-rated movies differ from those of PG-13 and PG-rated movies? Discuss both the slopes and intercepts. So first, what do you notice about the slopes of these lines? They go up. They're pretty similar slope. I mean, they're a little off, but they're relatively similar. So, all have pretty similar slopes. What do you notice about the budget in terms of like talking about the y-intercept for those 3 types?
So what?
Like, what do you notice about the budget? So, like, in terms of the y-intercept for the 3 types.
The budget for red arteries are smaller.
So, the budget of the R-rated movies is much lower because it has a lower starting budget. Okay, so let's look at number 12. So this is going to be the stuff that we...
Are we not doing C?
Is there a C?
It's at the top.
It's at the top.
Oh, lol. The film King Kong, with a runtime of 187 minutes, is the red point sitting at the lower right. If it were omitted from this analysis, how might that change your conclusions about PG-13 movies?
Well, it's technically an outlier, so it wouldn't really affect it very much.
So taking out an outlier isn't going to change anything.
Well, it would, but like not like a humongous drastic change. but I mean, it would make it seem more like PG-13 would cost more the longer.
Yeah. So, removing that point would probably increase the slope and make it seem like it's PG-13, right? Yeah, PG-13 movies have a higher budget. Now we did all the parts. All right, number 12 then. So this is going to be using kind of this stuff here that we looked at yesterday. So you might want to have that like handy to flip back and forth between. Which I'm actually going to grab my paper so that it's easier than scrolling.
Is it 12?
Yeah. And the graphs for 12 are at the like top of the next column. So, well, this problem says each of the following scatter plots shows a cluster of points and one stray point for each. Answer these questions. So basically what I'm going to do is I'm going to answer question 1 for A, B, C, D, and then I'm going to answer question 2 for A, B, C, D. So that way it's just easier to look at it. So part 1, A. In what way is the point unusual? Does it have high leverage, a large residual, or both? So the point that is to the left of
I say high leverage.
high leverage. Let's see. What about B?
High leverage.
Yes, high leverage. Let's see.
Low leverage.
Yep. And D. Are you guessing?
High leverage.
It's high leverage. No, I'm going to look because in the back they actually do these little explanations with them. So let me.
It's like, is it like the higher it is, it's higher leverage?
Like
Well,
how
so
far
let
away
me.
it is.
So I'll go through and next to each one, I'll put the little reasoning that the book actually gives with each one so that you can see. Because I think sometimes hearing the reason helps a little bit.
Or is
So-
it like the farther away from the
Well, to an extent, it's how much does it change the residual value.
Oh, yeah.
So like for A, okay, it was that it makes a large residual a little bit smaller. For B, there was just a small residual in general. Because there wasn't, like, the line that you would be fitting to the curve would not really be that, yeah, there wouldn't be that off. For C, there's a large residual, so it was off from the line. Because, like, in A, like, if you had made major line through the points, it would have still had the point not that far off. But in this case, because of the line, it would have been a higher slope. That point would have adjusted it. So, that one had a large residual.
So when it has a large residual, it's low, and then when it has a smaller, it makes it smaller, it's high.
Yeah. And then high leverage is the small residual again for the last one. So again, it's not really off from what the pattern would have been in terms of your line. So you got to think, like, when I have my best fit line on there, what is that point doing? Like, how far away is it from that line that I would draw? And I mean, yes, you're kind of just eyeballing where the line would be, but the line should be pretty much splitting your points in half that you have. So it's thinking, like, if I removed it, what's going to happen kind of thing, a little bit. Okay, so then 2, it says, do you think that the point is an influential point? So, let's see. A, B, C, D. So, if it's right, then why do you say no, not influential?
Because based on this graph I'm looking at, influence, it looks sort of like that. And it says not influential. Therefore, it's not influential.
I'm checking
I know
something.
it's not, because it's not close to the graph, so it's not that. It's not going to influence the
So,
I would say it is influential because it is far away. Farther from the other one.
yeah, so if it's not really following the pattern, it's influential.
Oh wait, hold on, say it again?
Like, if it's not really following the pattern, it is
It
influential.
is influential.
Like, if you take it out, it's
Yeah,
gonna
yeah.
make a
That
big
makes
deal.
sense.
Like, so if you looked at the, let me see. Like the bottom middle one that we did, that one, it's like perfectly following the pattern. Like, it was in a step pattern, so it was like perfectly following. So it was not influential because it's not, if you take it out, it's not really going to change anything. But the ones where, like, you take it out and it's drastically going to change, that's what we're kind of looking for.
So they're all influential except for D. And B. Well, not B.
So,
B is influential.
B and C are influential.
Yeah.
B is going to be, yeah, B is influential because you have everything, like, right there together.
Yeah.
And then that one's, like, way off by itself. So that one is going to be influential because it's going to pull it a little bit. C,
Oh, it's always not.
it's not.
Well, that's unfortunate.
Because it's still technically, like, that one's not going to change that slope very much of the line by removing it.
Okay. And then B is not influential.
Right, because it's following the pattern there. Let's see. 3. 3 says, if that point were removed, would the correlation become stronger or weaker?
For A,
Yeah.
correlation would be strong.
Yep. And to that one, because the correlation would increase because the scatter would decrease. So there's less scatter, then everything's kind of right there together. So that's why it would become stronger. B.
You said again? Sorry.
Yeah, so there, when you take it out, the correlation's going to become stronger because there's less scatter. So there's not something that's like
Okay.
off by itself.
Okay.
B.
I want to say stronger, but I would say weaker.
What do you think, Joelle?
Is moderate an option?
No, stronger, weak. Like, we're just saying it's getting stronger or it's getting weaker.
I'm saying weaker.
Stronger.
All right, so it is weaker.
Gosh dang it.
Okay, because in that case, by the point being there, it's going to make it, it's going to bring out your slope.
Oh, yeah.
So when you take it away, then you just have a whole bunch of scatter right there,
Okay.
not really following any kind of a pattern. C.
Stronger.
Stronger. It's going to pull it up a little bit more.
And
D.
is weaker.
Yep. Because it'll split the points a little bit differently. Let me see. Did it? No, not really anything exciting to say about that. And then for part 4, if that point were removed, would the slope of the regression line increase or decrease? So for A, it would increase. What about B?
Decrease.
Decrease. Also, about the same is also an option for this one.
Oh, nice.
So what about C?
About the same.
Yeah, it'd be about the same probably. About the same or decrease slightly would be what I would say for that one. Because taking it out, it's going to, instead of pulling it, it's, I mean, not super noticeably going to pull it down, but it could. And D.
About the same.
Yeah. And again, that one could decrease slightly as well, but probably about the same. We're gonna do one more problem, but number 11 is like this, so I'm gonna assign 11 for you to do, and then if we need to go over it tomorrow, we can, or well, Friday, whatever. Tomorrow will be a day for you to work on the problems probably because we have time, and then Friday we'll do a little bit with chapter 10 that we're gonna do. So, okay.
10 pages.
Yeah, well, we're not doing all of it. All right. Last one that we're gonna do out of the book is number 18.
Oh, about grades.
So, a college admissions officer defending the college's use of SAT scores in the admissions process produced the graph below. It shows the mean GPAs. Whoa, my thing is falling. For the last year's freshmen grouped by SAT scores. How strong is the evidence that SAT score is a good predictor of GPA? What concerns you about the graph, the statistical methodology, or the conclusions reached?
So the evidence is very strong. I don't know what I just did.
Well, using my GPA and then the SAT score that I got. That's terrible.
So, yeah, probably moderately strong to fairly strong.
My SAT score not
Yo, my SAT score was
even.
terrible. But I'm also a terrible test taker.
Mine too. I had a 1040.
I currently have a 1,000 flat, but anyways, I'm taking it again in December. So.
My brother had 14 something.
That's crazy.
I don't know how.
It's not even fair. My cousin, as a sophomore, took the ACT
He's
and
an
got a
SAT.
32
What?
as a sophomore
That's crazy.
Wait, 32?
out of 36.
All of us say 32 out of 60.
I got,
32 out of 60.
I think I had a 25.
Yeah.
I did better on my ACT than my SAT.
Yeah, my brother, he took SAT right now.
For Liberty to get like the valedictorian scholarship, you have to have a 1350 on your SAT, and I was like,
Yeah,
don't
I know. Well, this right here should prove. No.
Yeah, exactly.
So, it's moderately strong because it's fairly linear. What is a problem with this graph that you see? Nothing about the data itself, but the way it's presented. What do you notice is a problem?
The lines,
What do you mean?
like how it's connected.
Like the dots?
Yeah.
Yeah. So the graph should be a scatter plot. So that's also a problem. With dots not connected. And then the other thing about it is that I would say the admissions officer chose data to fit his model.
That's true.
Because there's no way that there's only that many dots with the amount of kids that he's talking
Yeah.
about. So I would say that the admissions officer, I cannot spell, oh my gosh, that was embarrassing. Admissions officer chose data to fit his model. All right, I'm going to go ahead and tell you the problems, and then we'll just look through the other page that I gave you just without the iPad. So,
Are these due Friday?
yes, 1, 3, 7, 11, and 17, and you'll have time tomorrow to work on them in class. So that way you can also ask questions as you go if you have them, because I know this section is one that's a little bit more confusing.
Except I like number 12. That was fun.